Let's take a look at another aspect of ski areas. Which area looks like it has the largest vertical drop? I'm looking at Copper Mountain right now. That looks pretty steep to me, but we could compare it to the elevation and the vertical drop data for selected ski areas on a website called howtoski.com. And there are other websites that indicate this kind of information, but this howtoski.com link is a good one. Also, you could use the form on www.onthesnow.com Colorado terrain to analyze whether the vertical drop distance influences the percentage of beginner, intermediate, and advanced ski runs that a resort has. And if so, how and why? Have the students examine the annual snowfall in conjunction with these maps that you've been analyzing. Which resort listed receives the highest amount of snowfall, and where is it located in Colorado? Next, you could add interest as well by examining a webcam to visualize the ski resorts that you've been exploring. For example, ColoradoWinterInfo.com has ski resort web cameras. And so you could look at specific ski areas and then find out what those actually look like on the ground. No matter what the season, these webcams are usually running. Lastly, a couple of things that you could do use for further investigation. Colorado has the most skiable terrain of any state or province in North America, with nearly 39,000 acres. Okay, in ArcGIS, we'll pop up our ArcGIS back up here. You could sort the ski area attribute table. We haven't done that yet, so let's go ahead and go back into the ski areas table. So ski areas, right-click, open the table. And see this area, this acres, we could sort it descending. So it looks like, according to this data set, Vail is the area with the most skiable terrain. It has 12,226 skiable acres according to this data set. Now, why do we say according to this data set? Because we always want to get across to the students that your analysis is only good based on as good of the data as the data that you have, right? If the data is lousy, your analysis is probably going to be lousy. So get them to think about the quality of the data is critical here. And I'll talk more about the data in a bit. Does the name of the largest ski area here surprise you? Aspen Mountain comes in as the smallest. As you can see, 325 acres. However, go back and examine the map. If we'll go ahead and zoom to, right-click there and zoom to the map. And I'm going to minimize this table. I'm going to zoom out, and there's Aspen Mountain. Go ahead and turn off the shaded relief. Okay. Yeah, Aspen Mountain is small in terms of skiable terrain, but the Aspen Resort Complex is huge because it also has Aspen Highlands and Buttermilk and Snowmass within pretty close proximity. And of course, with the GIS, we don't have to say pretty close. We can actually measure. So 2 miles away is Aspen Highlands. Buttermilk is 3.6 miles away, and Snowmass is 6.5 miles away. So they're all within 7.5 miles of each other. So which adjacent areas increase the combined skiable terrain near Aspen? I would say Aspen Highlands, Buttermilk, and Snowmass. So folks, with minimal effort, rich data sets can be used, as we have done here, to investigate spatial patterns with GIS. After your GIS analysis is done, get out there and hit the slopes. But remember to bring your GPS with you so you can map your runs after you're through. So ask the students, what have they learned about the spatial pattern of Colorado ski areas in this activity? Secondly, how has GIS and spatial thinking enhanced their understanding of ski areas in Colorado? Of course, you could do this for anywhere. We've just highlighted Colorado because it's fun and because we could get the data. We'll talk more about the data in the next segment.